Hello, my name's Ross Anderson, a 40-plus year veteran of weights and measures, and someone who's going to ask a stupid question. What is the verification scale division? I do that in honor of Ask a Stupid Question Day, which is the 28th of September. For most of you, it's a stupid question because the verification scale division has been part of our vocabulary for over 35 years. You'd think we'd know what it is.
The verification scale division, the term, enters our vocabulary in 1984 with the adoption of a new scale code. What the NCWM did was replace an older scale code based on mechanical analog technologies with a new scale code that is technology neutral, and that was based on R76. In R76, E for me is essentially a code that the manufacturer declares capacity, class, and E, and from that we can calculate the tolerances for any weighing instrument. So the key here is that verification is verification, and it isn't solely applicable to weighing instruments. Verification is applicable to any instrument. And so what I propose to do is look at verification and the verification scale and the verification scale division in terms of another type of instrument, and the instrument I chose is the motor fuel device. When we test the motor fuel dispenser in verification, we dispense product from the instrument into the test measure until the instrument reads 5 gallons, 5.000. We then turn to the test measure and we read the error from the error scale as -3 cubic inches. But of course, this is a shortcut. There's more to it than that, because actually what the test measure is measuring volume with 1155 or 5 gallons at 0, so -3 corresponds to 1152 cubic inches, and we have 5 gallons on the instrument scale. What we then do is we say the error is the true value from the test measure minus the indication, 5 gallons or 1155, we get -3 cubic inches. The question that we need to ask is, where is the verification scale? Now we know the verification scale divisions is cubic inches, but where is the verification scale? People will immediately turn their eyes to the instrument scale because that's what we've been attuned to do, but we need to look up and see that the verification scale is associated with the test measure. And the test measure is the true value scale, which is absolutely essential to verification. We have to know what the true value of the delivery is. So the E scale, the verification scale, is actually on the test measure, not anything to do with our instrument. Now I want to do a slight variation. What I'm going to do this time is I'm not going to stop at 5 gallons on the instrument. I'm just going to stop anywhere. In this case, we happen to stop at -1 on the error scale, which is 1154 on the verification scale, and we get 5.01 on the instrument scale. Well, what's the error? Well, it's 1154 minus 5.01 gallon, which is 1157, is still -3 cubic inches. But notice that the error scale that we worked so hard to get on our test measure is no longer useful. Now we're going to do a third variation on the verification. And what we're going to do this time is we're going to use a test measure that only has one mark. That one mark is at 1155 or 5 gallons. We are going to stop the test when the test measure reads 5 gallons or 1155. Now we go down to the instrument scale and we see that it reads 5.014 gallons. Well, 5.014 is 1158 cubic inches, 1155 minus 1158 minus 3 cubic inches. So we did 3 different ways of doing the test, came out with the same answer, minus 3 cubic inches. Now we could have built an error scale next to the instrument scale. And notice that at 5.000 would have been 0 error. We're at 5.014, we're at minus 3 on the error scale. But notice that the error scale is now next to the instrument scale. Earlier, the error scale was next to the verification scale. What we need to realize is this error scale that we create is in limbo between the two scales. And how does this work? How can we read the error from the instrument scale? Well, it comes from a very simple axiom. Over any small range of indication, the instrument scale divisions D are uniform. Now they have to be uniform according to GS 523, and think of it in terms of each division should be accurate to about 0.5%. Now I defy you to see 0.5% of a 1 cubic inch graduation on a test measure. It's just too small. You can't see it. And that's why, for the purposes of tolerance, we can say that 6 cubic inches is 0.026 gallons on the instrument scale. And of course, the true value divisions are without error. So it's time now to circle back to our weighing instrument. And now I think you should see why I did the last example on the test measure, because this is what we're doing when we put a 1,000-gram weight on a, let's say this is a 2,000-gram capacity scale by 0.1 gram. Our instrument reads 1,000.1 gram minus 1,000 is plus 0.1 gram or 1e. And we have the exact same situation, but notice there are no verification scale divisions that we can see. They're virtual. And where does the error scale show up? Well, the error scale shows up next to the instrument scale, just as it did before when we stopped the test at 5 gallons on the test measure for the retail motor fuel dispenser. Now let's go to E equals 10D. We apply the 1,000-gram weight. It reads 1,000.06 grams minus 1,000 grams plus 0.06 grams, which is 0.6 E. Nobody's confused about this. That's the error. And we could, of course, build an error scale very easily, where it was not so easy with the test measure. We build a scale E next to the instrument scale, and we see that we are at plus 0.6 E, or 6D. Now people are going to balk. They'll say, wait a minute, that's not what the handbook says. And one of the things they'll turn to is Note 1 of Table 3. Class 1 and 2 devices equipped with auxiliary reading means. These are riders, verniers, or least significant digits that are differentiated. The verification scale division E is the scale division immediately preceding the auxiliary means. And this is how we have read this section incorrectly for 35 years. If we now go and read all of the words, we find that the value of the verification scale division E is the value of the scale division immediately preceding the auxiliary means. It means they have the same value, but they're not the same. They're the same because of S1221, not because the verification scale is somehow associated with the instrument display. Now look at the definition of the verification scale division is defined as a value specified by the manufacturer by which tolerance values and accuracy class applicable are determined. How does that have anything to do with the instrument display? It doesn't. Look further. The second sentence. Verification scale division is applied to all scales, in particular to ungraduated devices. Well, how can you say that the verification scale is part of the instrument scale when you have an instrument with no scale? The verification scale is referring to the reference value of the standard. And finally, the verification scale division may be different than the displayed scale division. Now, why is the word displayed here? Because the verifications is declared. It's not displayed. Now, if I were to digest this all down, distill it all down, I can get it down into two basic slides. When we're doing delivery error, the verification scale is always a constant. It doesn't change. It's 100% accurate. It's without error. We're always verifying the instrument scale against this verification scale. And for delivery error, it's the E scale reading minus the D scale reading. That gives us delivery error. So when the divisions are too small on our instrument, what we see is the instrument scale shifts left on this diagram, the error goes minus, we're in deficiency. If the divisions are too large, the scale shifts right, we go plus error, and we are in excess. When we switch over now to indication error, as in the case of a weighing instrument, again the verification scale is constant and true. The instrument scale shifts. When the divisions are too small, the error goes plus. This is over registration. When the divisions are too large, the error goes minus. This is under registration. And the error of indication is the D scale reading minus the E scale reading. But there's another piece of the puzzle. And there's the piece that it deals with digital rounding. And this got lost in translation because there's nothing in Handbook 44 about this. When you round to a digital division, you can make an error of plus or minus a half of a division. But R76 says that you must eliminate that rounding error if the actual scale interval is greater than 0.2 E. So whenever we're applying tolerances, it reduces the effect of the rounding error to 0.2 of the smallest tolerance, which is actually 0.1 E relative to 0.5 E. So what does that mean? Well, look at this diagram. When we have an instrument with a 1 E tolerance, we see that errors are normally rounded. That means an error of 0 represents errors between a minus a half and plus a half. A plus 1 error is between plus a half error and plus 1.5 error. Now technically all of those things greater than 1 up to 1.5 are being falsely accepted when we apply the tolerance. But notice what happens with the retail motor fuel device, where now we're using 6E. Now we reduce the amount to 1/12 of the tolerance, half of 1E in rounding. Handbook 44 does not address this, and I think you can make a very powerful argument that you can't use error weights, that half an E acceptance, because of digital rounding, is part of the scheme. And we need to fix that. If I were to summarize then, it's very important that we realize that the verification scale division E is connected to the reference standard, but it's visible with an instrument like the 5-gallon test measure, but it's virtual with an artifact. But the E division is there for calculating tolerance values, not so much for readings. The D and the E scales are independent. D is displayed, relates to the indications and functioning of the instrument. E relates to classification and determining the value of tolerance. This is the true value scale. And then finally, error is the difference between the indication and the true value, and the order in which one you subtract from which depends on whether you're doing delivery error or indication error. And the true value is always measured on the verification scale. So the ramifications, well, I hope now, after seeing this, you will never again be confused when you see an instrument where E equals 10D. So just as we're not confused by the 0.001 gallon increments on a fuel dispenser, and we're applying tolerances in cubic inches, we should not be confused. All you have to do is convert both the tolerance and the readings to the same units of measure. But the real ramifications, the real thing that we need to talk about, is that technical specifications refer only to D and not to E. You'll notice that in the handbook, these are referred to as scale divisions, not verification scale divisions. And without the word verification, we must apply it to D. Now, I'd like to just give you two quick examples. There's a motion detection requirement when you press the 0 button. And it says it has to be stable within plus or minus 1 division. And is this E or D? Well, think about it. If it's E and you capture 0 while it's in motion, when it stabilizes, you may get a 0 anywhere between minus 0.1 and plus 0.1 gram, or essentially plus or minus 1 E. Not very good when you're trying to zero it out to a tenth of an E. If you understand that this applies to D, then the result is going to be between minus 0.01 and plus 0.01. We've got 0 where it belongs. And finally, discrimination. TN72 requires the zone of uncertainty to be 0.3 division. Is it D or E? Well, of course it's D. As it turns out, the least significant digit on a weighing instrument or any digital instrument is the only division that is rounded. All of the divisions to the left, all of the digits to the left of the least significant digit are counted. They're not rounded. There is no zone of uncertainty. The only zone of uncertainty is between successive scale divisions D. So I thank you for listening, and I hope that maybe the stupid question of what is the verification scale division turned out to not be so stupid. And I hope this helps in our understanding of the issues surrounding Class II scales as they're used in the cannabis trade and in other things. Thanks again for listening.